Welcome, ladies and gentlemen, here at the Hannover Fair of 2023. You are at the Hydrogen and Fuel Cells Europe Forum, where we, like all day long, have nice talks with interesting guests. So you see the people behind the technology, you learn more about the technology and about what drives those people, what they want for the future. And you also have the possibility to ask questions to our speakers. In any case, you do have a question, raise your hand, and then I hopefully see you. Be a little bit patient with me, please, and then you can ask the speaker directly. So have a drink. The drinks are for free. Take a seat. My name is Mareike Schmalz, and the next topic on stage will be hydrogen fuel storage cylinders and systems. And I'm happy to welcome our guest. He is Alternative Fuel Business Development Manager at Luxfer Gas Cylinders. Welcome, Jim Gregory.
Thank you, Mareike. Oh, wonderful.
Have a seat.
I will.
So, nice to have you here. I hope you're having a good day.
Yes, definitely. Busy day. I think yesterday was busy. Today is busy as well, which is wonderful. Wonderful.
Yeah. Nice to hear that you're doing a lot of business.
Yes, I think our poor guys on the stand are talking all day long, so they get very dry mouths about 5 o'clock, and we're in Germany, so you know what happens when your mouth gets dry.
On stage we have water only.
Oh yeah, but everyone else who's been on has been drinking this. I'm not sure it's very hygienic.
You got a fresh one.
Oh, fantastic.
We'll make that sure.
Okay.
So to give the audience a little bit of background, Luxfer is a manufacturer of high-pressure composite and aluminium gas cylinders, as well as also you offer hydrogen and CNG fuel storage solutions.
Indeed, yes.
Yeah, so could you tell us a little bit about your company and give us some examples? Maybe the people might already know your products from everyday life.
Indeed they do. If you probably go around the hall, fire extinguishers.
Okay.
So if any of you flew here in a plane, you probably find that the inflatable rafts are powered by a Luxfer cylinder that blows compressed air in when you don't want it to happen, obviously, because the plane would be crashing, but you would know that it worked. So it has to be very reliable. And then the more high-profile things you'd see is scuba tanks. So we developed the first scuba systems with Jacques Cousteau in the 1960s. And then...
that's quite early.
Yeah, we provided the breathing apparatus for the Chilean miners when they were being rescued, and we provided them for the Thai children's football team a few years ago when they had to be rescued from a cave. So we provided the tanks for that. So those are nice things. But in the context of this show, obviously, we provide hydrogen storage systems, primarily really for anywhere you need a lightweight tank because you're transporting the gas either on a vehicle, so the cars and the buses, or in a tube trailer, and you're taking gas from A to B.
Okay, thank you. So, as we just heard, you already rescued a lot of people with your technology. Now, next up is Save the Planet. So, regarding the topic of sustainability, what importance does that have for you?
It's great for me. Obviously, the mission of the company is to create a clean and safer world, and that's our clear mission statement in everything that we do. So whether it's oxygen tanks for hospitals or it's the hydrogen tanks for decarbonizing road transport. Personally, it means a lot to me. I started out in the automotive business 34 years ago, and everything I did polluted the planet. It's nice that the back end of my career that I'm actually working on something that I can be proud of and is saving the planet. So it's a huge motivator for all of us. It's a very strange industry. We're very energy intensive in ourselves and what we make. It takes a lot of work. So we're trying to reduce our own emissions by 20% over the next few years, and we've already got to a point where we don't put anything into landfill from our manufacturing sites. There's always work to be done, but we are clearly focused on it every day.
That's lovely to hear. So I really enjoy. I'm really happy to hear that the companies here on stage, and in this case, you and your company in particular, are not only saying, okay, we look at sustainability by providing products for other people to use, but we also look at our own actions on a daily basis and try to improve wherever there's room for improvements.
Definitely.
So that's great. So when we talk about hydrogen, we talk about the smallest element, the smallest molecule in the world. So it is quite tricky to store that one. So can you tell us a little bit more about the technical challenges?
I think it's a good question. I think there's probably two technical challenges. One is fairly obvious. The first one is the fact that hydrogen being the smallest molecule and we're stirring it at quite high pressures, it wants to escape from everything you put it into, and it permeates through an awful lot of things. So even some of the cylinders we make metal, solid metal cylinders, metal-lined cylinders, plastic-lined cylinders. There is a certain amount of porosity, particularly on the plastic-lined cylinders, so there is a certain amount of gas that is always permeating. It's a lot better on metal cylinders because it doesn't pass it passes a negligible amount of hydrogen. But the industry in general, all of us and all of our colleagues in the gas cylinders industry, we're working on reducing all the permeation across all of the systems, and we also have to make sure that all components tend to require a higher level of precision when we're dealing with hydrogen. So when we're building methane-based systems, methane's not quite as prone to escape from the cylinder as the hydrogen is. So we tend to have more expensive and more precisely engineered components. But I think the big one that most people don't get is it's the Joule-Thomson effect. Actually, is the biggest bugbear when you're making hydrogen storage, because hydrogen and helium, unlike every other gas, at the temperatures that we use them, they heat up when they go through orifices, when they're throttled, and hence you get a lot of heat build-up when you're transferring gas into tanks, refueling your car or refueling your bus, but also when you're transferring out from a storage system into another storage system. And what that means is you get rapid heating up of any orifices and valves. You get hot spots of heat in the domed areas of cylinders, for example. And that causes, basically, in brutal terms, it takes longer to fill up your hydrogen bus than perhaps you would expect.
Okay.
And so we have to, as an industry, we have to spend a lot of time making sure our refueling systems work as efficiently as possible and as accurately as possible. And we do have to protect the cylinders and all the equipment from overheating. Hence, it's a little bit easier with the metal cylinders because they tend to dissipate the heat, but with the plastic cylinders we do have to put a bit more in terms of temperature control and security to make sure we don't damage the cylinders, and then they have to go to scrap. So I would say far more of our energy and effort is put into solving that problem than actually the permeability at the moment.
That's a very interesting one, because I think that many people might be hearing that for the first time. Can you give us at least a little estimation, like how long would it take a bus to be refilled if we didn't have that problem, and how much time might we lose because we have to take care of those thermal problems?
A lot of our experience is in the field. So we've been building the hydrogen buses for about 12 years now. Probably 2011, 2012 were the first ones in Europe. And we built up a lot of experience. So there are some instances where buses take 25 minutes or even 30 minutes to fill up, others where they take 7, 8 or 10 minutes, and that's the variation we're getting. Unfortunately, a lot of it's about chilling of the gas. So it's easier to fill up a Toyota with 5 kilograms of hydrogen in one shot because your chilling system will be sized to do that. Yeah. When you have to fill up 40 kilograms in an equivalent time, you're going to need 8 times the size of chilling. It's expensive. The plant costs a lot of money and is quite sensitive, so it can break down. So a lot of the problems we've seen have come from not chilling the gas enough, and therefore everything heats up. On sunny days in California, it takes a long time. So, yeah, 7 to 8 minutes would be a good, but the worst we've seen is 25 to 30 minutes, unfortunately.
Unfortunately, yeah. Oh, I see a question from the audience. If I might
Yeah, fabulous.
bring that to you.
Hello, thank you. I would like to ask, what pressure do you use for the storage, or is it different depending on the use case?
Oh, it is different depending on the use case. So it depends on. Every project is different. So we're currently running projects at 250 bar storage in vehicles, right up to 700 bar storage in vehicles. And then in the transport of gas, it's even worse because traditionally hydrogen's been transported by the big gas companies, by Linde, Air Liquide, etc., at less than 200 bar. And now we're moving to a situation where people want to transport more and want to compress it to 300, 350, 500, 700, 900 bar. So it just means we have to develop a ridiculously wide range of cylinders for all of these applications, because it's fine to transport gas at nominally, let's say, 450 bar, but that's no good if at source they can't compress it to that. So then they need to buy compression equipment to fill the cylinders with 450 bar. And that's a cost that they perhaps don't understand at the beginning. When we look at the practical sweet spot of transporting gas, for example, we find it's about 300 bar, most of our customers. The cost of compression, am I going into too much detail? I could do this on the stand. Sorry, everyone. I only have 18 minutes.
No, you're welcome.
And 2 songs as well, so I have to fit them all in. But basically, we find the sweet spot at about 300 bar, because that's when the cost of compression is not too prohibitive, and it transfers the cost of compression a little bit to the end user, but more often than not, that suits them fine. And obviously, in vehicle systems, the industry in cars is very much oriented on 700 bar, but almost every other application is in and around 300, 350 bar at the moment. No problem, no problem.
I see a happy face. So
any request on the song? No, I'm joking. No, really, I am joking. You don't want to hear that.
Can we hear it at the booth, maybe?
Yeah, at the booth I will sing.
Great, I can't wait for that one. So you were already talking a little bit about the areas of application for your products. I want to talk a bit with you about your typical customer. Like, who is your typical customer, and how important is it to you to have the direct dialogue with the customer to develop the right products?
Yeah. Well, it's very important because most of the time customers come to us with probably not very much knowledge. So they're not gas specialists. They are either existing big companies in another sphere, another field, but have never worked with gas before, or else a large proportion are really smart startups. The people you see in this hall, they can't be experts at everything. This is a new field. So what they're really looking for is expertise and collaboration, really. They're looking for partners. It's not, at the moment, it is not a commoditized industry where you just buy off the shelf. You need dialogue. So we spend a lot of time designing bespoke systems for our customers. I think in the last 7 months, we built 15 different vehicle prototypes. And I promise you, don't ask for standard. It never works. Every job is different.
That was just what I wanted to ask you.
Yes.
Like, do you see a chance for it becoming like a commodity product, or is it a field where you say, okay, no, we'll never have one solution that fits them all?
No, it's
No,
not
you already
yet.
answered it, yeah.
No, but not yet. And it's a wonderful industry to be in. You think about it. We've had 120 years of parallel silos in marine and rail and automotive and power generation using diesel and liquid fossil fuels. But they kind of just grew up in these silos. Now we have about 10 years for all of them to change what they do. And so literally every inquiry is a bus, a boat, a plane, a barge, drones. It's every day is different, and their demands are different. It's fascinating, but there is no standard.
Okay, thank you. So I'm also quite interested because we hear that you do have a lot of knowledge. I would like to know what personally drives you. You've been in the industry for a while now, and maybe there are some personal highlights or milestones that you experienced along the way that you look back on with particular pride.
Personally, I love the fact that we do something different every day, and it's a lovely field to be in if you're doing something different, and it's the same for everyone in this hall, I'm sure. And it's great to know you can do something that is of genuine use to the world. Is that you're doing something genuinely good. Don't invite me to a barbecue because I'll be very boring about hydrogen, but you can get very passionate about the subject. As far as sort of milestones, there's a different vehicle launched every month, so they're always very interesting. Probably the highlight for me personally was COP26 when we got a royal stamp of approval from King Charles III.
Wow.
Well, that's a bit of a lie because he didn't give his royal stamp of approval. He can't do that. It was before his involuntary promotion at COP26, so we'd built a hydrogen train that was on display, and Prince Charles was given a tour of the whole system, and plenty of photographs of him with Luxfer gas cylinders equipment. And what's really lovely is he spent 10 minutes asking detailed technical questions about how fuel cells work, about how the power's transferred, about what the storage does, all this thing about hydrogen, which is great for me. I've been a big fan of his from being when I was a kid, because he's always been a campaigner for the environment, and that was really wonderful. What was also interesting was that the Prime Minister of Britain at the time, Boris Johnson, also visited COP26 and also had a tour of the train system, and he did not ask any in-depth questions. He did not spend 10 minutes. I think he spent 17 seconds, we counted, so yeah, that was interesting. That was an interesting view on the difference between the royal family and a politician. There we go. Is this going to be on YouTube? Am I going to end up in the Tower of London or something, or in prison? That was a great day. That was a great day.
So, to the audience, you see what privilege you have here. You can ask the same expert that Prince Charles, now King Charles, was able to ask. So in case you want to make use of that privilege, just give me a little sign. And I guess now they are intimidated because you are almost royalty, you're so close.
Yeah.
So let me ask one last question to you. So what developments do you see in the market, and what developments would you like to see for the future happening in the market?
I think we see the current trend. We've been a bit guilty in the hydrogen world. You know, people who do this, and we've been doing it for many decades, we've been a bit guilty of focusing on the mobility and getting lots of glamorous trucks and buses and boats made, but haven't had enough gas. I mean, the truth is there isn't enough hydrogen out there to power all the projects that we'd all love to do. I think that's changing. I think certainly up until the end of next year, the focus in terms of what we sell is about gas transport. So I see that as a wonderful, positive sign that finally we're getting enough power, enough electrolyzers online and generating enough hydrogen that we need to move it about to these end users. And then that, I think, from end of 2024 onwards is when we'll see this true, we call it the hockey stick growth of hydrogen vehicles and hydrogen mobility, once we really know we have the established infrastructure for production of hydrogen and distribution. So what would I like to see? I'd like to see all those lovely electrolyzers online, and yeah, I can sell even more stuff.
Thank you very much, Jim.
Marika, it's a pleasure.
It was a pleasure to have you here. I'm so sorry that the time is already over. But
I don't think the audience is.
So, thank you very much. Have a great time at the fair, and hope to see you again in the future.
Thank you very much. Thanks.